So good morning once again. The session is now being recorded, so I advise that to ensure privacy where necessary. So uh, I, I want to share my screen. Let me know if you are able to see my screen. Are you able to see my screen?
Yes, sir. You can see it.
Okay, so this is our classroom for those who have not been there. As a matter of fact, if you click this page, you will see the the lecturers. Uh, Oni is available, Kafayat is available. These other two have been facilitating with me in the past. So these are the list of those who have joined the class so far. Who is this La, Larry Roll? He's been invited, but is yet to join. Is yet to accept the invite. So it's very important that you join this classroom and be sure that you are also listed here. So on the classroom page, that's you see resources for you to use, and you don't need to wait for anybody. There are previous quizzes. If they are open, then you can also practice with them. There are practical exercises. There are previous assignments. So if you are giving fresh assignments, they will also be there. There are tutorials organized by Peter in the past. The videos are there. There are ebooks that you can also leverage on, particularly this one. Uh, so some of them use R, mostly R. So you can take your time to harness those resources. There are also the you know uh, previous lectures that are uploaded, so they are all here. You can have a, a, a view of them. This is you have for lecture, course overview and introduction. So you can even be ahead of the class because you can watch all these previous videos. Even today's own will be uploaded when the video is compiled. So you have no excuse. This is digital age, and uh, we cannot continue using the traditional, um, you know, dictation notes, dictation of lecture notes and blackboard, all those things again. So you have to get used to this because we cannot, no, we cannot afford to be left behind. So, of course, in your own, you won't see the grade, but any assignment, the grades are provided here, but you won't see it. So make sure uh, when you are given assignment, you do it because the the grades are recorded, electronically, digitally. So anytime we have the lecture, you always come here under the stream page and you simply click join so that you can be part of the class. Uh, Apart from this, let me also show you that some of these lectures are also on my uh, YouTube. So if you go to my YouTube channel, you can search for my name and subscribe to the YouTube channel. Um, so my channel is uh, this is my YouTube channel. You can see some of the uh, uh, lectures on um, yeah, so you can search for PGM. No, this is okay. You just click videos and maybe here you search for PGM. Uh, proba. I hope you are able to see my screen. Probabilistic. Okay, so you will see some uh, previously delivered lectures. If you search, so you have not only on PGM. I don't know if I've uploaded PGM, but you will also see uploaded lectures on different uh, uh, data science related lectures. So feel free to come. Let me share the channel link for those who would like to visit. So I'm going to share it with you on the chat menu. If you go to the chat menu now, you will see the YouTube link. So make sure you subscribe to the channel. You can also encourage your colleagues, your friends who would need any lectures, uh, support on uh, whatever aspect of statistics that you think will be helpful. So that's that. Let's now go to what we have for today, which is to basically introduce ourselves to um, the PGM. I hope you can see. I hope you can still see my screen.
Yes, sir.
Yes, sir.
Great. So, this is the lecture manual, the course manual for probabilistic graphical model. The manual actually is a compendium of lecture notes previously delivered on this course, uh, which I have put together. But this particular manual is simplified uh, because this time around we have people coming, students from the Department of Linguistics and African Languages. Do we have anyone now joining us from linguistics?
Yes, sir. Yes, sir.
Please introduce yourself.
My name is Robert Oluwapomile Fasheitan. I'm a student of Masters in Computational Linguistics. My
Yeah,
background is I have a background in computer science, HND, and
okay,
Bachelor of Arts in Linguistics.
okay. That's great. That's great. Anyone else?
Yes, sir. Good morning, sir.
Good morning.
Yes, sir. My name is Kasaba Abib, sir, from linguistics. My background is linguistics. Currently, master's computational linguistics.
Great, you are welcome. Anyone else? Okay, some are trying to join. Let me admit them, and let me also make. Okay, I think Kafayat, you
Yes, sir.
are
We can do that.
okay. So please you admit those who are joining. Anyone else? Anyone else from linguistics? None. Okay, fine. So um, now we have a course that is, you know, cross-cutting in a way, and I'm happy because, particularly for our MSc statistics students, not just MS, any statistics student who can now see the applications of some of the things we learn in statistics. I want the two groups to mix very well and learn from one another. So this manual is packaged in a way to embrace um, linguistics applications, mostly. So some of the examples will have uh, relevance in linguistics. But the course itself, as you will learn very soon, has application in other fields, medicine, education, and so on and so forth. If you have not gotten your copy, you can get copies. We have printed copies. We also have e-copies. Uh, so you can get the e-copy for 2,000. You can get the hard copy for 5,000. You can also, it's not meant for, I mean, you can introduce it also to colleagues in other disciplines. for those who are committed to apply PGMs in their research or projects. So I will leave you to go through the preface, which provide adequate background to the manual. I deliberately want us to follow the manual so that we will be able to explain some things. My hope in future is to upgrade the manual to a text book. So some of your input, your criticisms will also help to improve whatever we have at present. So in the book, we have about 15 or so chapters, and the coverage include foundations of probabilistic reasoning to representations and model structures to how you learn from data. And of course, we have applications and extensions, and you also have practical exercises and data sets for you to ensure that it's not just the theory, but you are grounded in the applications. So if you look at the earlier, we asked you to read the chapter 1 ahead. I believe some of you have gone through the chapter 1. If you have gone through the chapter 1, type yes in the chat menu. If you have read chapter 1, type yes in the chat menu. Type yes in the chat menu. Nobody has typed. If you are Oyele, yes. Gabriel Akaji, yes. If it's no, type no. Because type no if it is no. So far, only 2 people have responded. Yeah, 3 now. If you have read chapter 1 before today, type yes. Only 3 people. If it's no, type no. Fasheyitan, what about you? Fasheyitan,
Sorry, I didn't quite get that, sir.
you didn't get what?
The question you asked, sir.
That you were asked to read chapter 1, before today's class. Did you take time to read?
Yes, sir. At least I read almost 70%, sir.
70%.
Yes, sir.
Of how many pages?
Of the 12, 11 pages. Sorry, sir.
No, is it 11 page? Yeah, it's about, but the main part is about just 2 or 3 pages. Chapter 1.
Yes, sir.
2
Yeah.
or 3 or 4 pages is what
Yes.
you have not read. Cassava, why have you not been able to read? People should have this caution of reading,
So we're deliberating about the course in the department with our course with our coordinator, sir. So we are not sure whether we are going to take this course. That's why, sir. I'm very sorry, sir.
But now you are sure. I'm asking that now you are sure.
Yes, sir. Yes, sir.
Okay. So, which means some of you now will be lagging behind because
Yes, sir.
after today, so you 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 will have to go back and read that chapter. But we are going to review that chapter together. Uh, Finally, Ghanaian joined. These are people who don't want to do the course. Am I correct, Ghanaian? They don't want to do.
Not that, sir. Just that we at the course outlines, we were a bit confused because we're not having the course code as part of the course outline. But now that we are sure that we can move ahead, sir.
Okay. So let's go back to the lecture. So here in chapter 1, the idea is to introduce this course, probabilistic graphical models. For those who have uh, taken time to read, you will know that um, the course is one that has real world applications, and you can apply it to solve practical problems. At the beginning of the chapter, we talk about attempt maybe by a researcher or by uh, an educationist trying to predict if a student will pass an exam or not. You will agree that uh, there are many factors that can influence a student passing or failing an exam. One of them could be uh, class attendance. It could also be the hours devoted to uh, study, and of course, um, rest is very important. Having good sleep. Um, so, medical practitioners will advise that for you to be in good frame of mind, you need good rest. Uh, your past performance could also be uh, a, a key driver to whether you pass or not. If a student has been consistently good, then that will influence the performance in the next exam. So, in most life problems, even ones that are more complicated than this, here we've listed about 4 possible factors. But there are in many other situations, you could have hundreds and thousands of factors that could influence whatever you are trying to investigate. So you then have a complex situations to handle. And this is where probabilistic graphical model comes in. So what probability graphical model does is actually to combine two powerful ideas or two powerful techniques. One is the graph theory, and the other is the probability theory. Just a minute, let me use another version. So, yeah, so let me use this version to be able to do what I want to do. So, uh, two powerful techniques are used: the graph theory and then the probability theory. Um, and from these two approaches, the name is coined. So in the name, you have probability coming up, and you also have uh, graph coming up. So PGM is a combination of two approaches, don't let me call it approaches, but two principles. So the 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 technique rests on these two principles: the graph and also probability. So we will be discussing about the graph. What does the graph represent? The graph represents the structure of the problem. The structure of the problem. So like we were trying to look at the student performance. Let's call the performance P. Sorry, my pen is not. Oh. Are you still able to? I don't know what's happening. Okay, yeah. So the pen is back now. So let's call performance P, and we are saying performance can be influenced by the hours of sleep, can be influenced by yes, remind me other factors that we talk about. Class attendance. Performance can be influenced by prior performance. So maybe we call it PP, that's prior performance. And of course, we said it could be affected by hours of study. So let's call that hour. So here we are representing all the factors in form of a graph, and we can now use something to show how which one is affecting the other. So in this discussion, it is the sleep that is affecting the performance. It is the what do we call the A? The how is it?
Attendance.
Attendance. Thank you.
Work schedule.
Is affecting the that is affecting performance. So this is attendance. This is prior performance, and this is uh, hours of study. So this is what we call a graph in a short form. So the graph is showing the way the variables or the factors, the way it affects or the way they affect one another, and the direction of the influence. So this is what we call the graph. So that's why you see graphical thing there. And then what about the probability? So the probability is measuring how the likelihood of that influence. So of course you will agree it's not the same way that hours of sleep affect performance, that the attendance affect performance. So probability helps to measure the 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 degree of certainty that we have, in this relationship. So in graphical model, we combine the graph with the probability theory. Whereas in the graph, you will see the circles are called the nodes. And this line, they are called the edges. They are called the edges. So what constitutes the graph is actually a function of the nodes and then the edges. So that's the definition of the graph. So in the graph, you will see the nodes. The nodes represent the variables. Always ask questions at any point. Feel free to ask questions at any point. So the nodes represent the variables, and the edges, that's where we show the direction of the influence. So in this one is showing that it is S, that is influencing P. So the probability is assigned, to the relationship as I mentioned earlier. So probabilistic graphical models, they are very important. Here, three main reasons are given. One, you can use this technique to simplify very large and complex models, or problems. Here, we have a problem with just few variables. You can have a very complex relationship whereby the influence can be cause and effect, which we are going to talk about now. So it's not just going to be that S is influencing P, but this can also influence this. And then you could have even performance influencing any of this. So, which means you have a cause and effect relationship. So, you can have a very complex problem. So, PGM can help to simplify this large problem. And then another benefit is where you have incomplete data, then you can still be able to use the PGM. That may sound very uh, uh, no, very uh, uh, impossible to those who have background in statistics. Uh, we are always more concerned when we have incomplete data. Some techniques will even break down completely. But PGM is a, is a technique that can work with incomplete data. And the third benefit is the visual representation that you see. So it's not all problems that can be, not all techniques allows you to have this kind of visual representation. And the way humans are wired, they like to see pictures, they like to see images, they tend to remember images, faster than when you have volumes of text, or data. So uh, the visual representation is a big, advantage, of this. So I'm not going to talk so much about the historical development of the PGM, but it all started, uh, with the discipline of statistics and the recent, uh, uh, expansion of, the recent development in artificial intelligence. So you could say that PGM is a brainchild, of uh, the field of statistics and the artificial intelligence. And that's why in language, artificial intelligence is helping machine to learn human language and also translate human language. So, but the detail of the history behind this is something that uh, those who are curious may want to go on. But uh, the two main disciplines behind this are, statistics and artificial intelligence. Uh, but we cannot, but mention names like Judea Pale, who developed the Bayesian network. You know, the Bayesian network initially was, you know, one that combined probability theory, with directed graphs. So, like the one I have here, you can see the edges are directed because you see the direction of influence. But suppose I have another, suppose I have another another graph like this, and I simply join this to this to this, and I say this is A, I say this is B. I say this is C. Let me also draw another one. And I say this is this. And this is this. And I have A, B, C. So this graph is called the Bayesian network. Why is it called the Bayesian network? That is called the Bayesian network because the edges are directed. You can see that B is the one influencing A, and you can see that C is the one. So A is being influenced by B and C only. So when the edges are directed, then it is Bayesian network. But when the edges are not directed, then it is called the Markov network. So here we don't know. We only know that there is a relationship, between A, B, C, but we don't know, you know, uh, the direction of influence. But there is a relationship. But here we know. So Judy Peel, if you call it that, actually started work on this Bayesian network. So uh, he worked on combining probability with directed graphs. So, and most of what we will be doing, even in this course, is going to be on the Bayesian network. That's why your course for the linguistic student, I think your course, the title is Bayesian uh, something probably. What's the name again?
Bayesian inference and graphical probabilistic graphical models.
Yeah, so Bayesian inference on probabilistic or graphical models, something like that. So this is the one we are going to be talking about, not the Markov network. So that's why we are talking about the pill, and trying to establish the origin of this discussion. Uh, Let me take a break at this point. Are there questions, comments, contributions? Or I should ask questions? I don't want the class to be one-sided. So I'm going to ask, I will call your name since you are not asking questions. Toyin, are you still there? Toyin,
Yes, sir.
you don't have any question? You don't have any comment?
Yes, sir.
What have you learned so far?
So far, I've learned that PGMs, combination of graph
Speak
theory and
louder. I can't hear you. I don't know if others are here.
Can you hear me now, sir?
Yeah, so you can do
So
better.
far, okay, sir. Yes. So far,
Probabilistic
Ah,
graphical method is a combination of graph theory and probabilistic graph theory. So, and you said we have the Bayesian network and the Markov network. So I told us that the Bayesian network is used when we want to the connection for the Bayesian is kind of is a direct I don't know how to put the word.
no problem. You've tried. Uh, Fasheyitan, are you there? I'm coming to you. Uh,
Yes, sir.
Abiola, I'm coming to you very soon.
Yes, sir.
Uh, okay, Fasheyitan, what do you want to add?
Uh,
Or
um,
at least improve upon from what I just said.
one of the things we've been going through for some time now is when it comes to machine learning and other aspects is Bayesian theorem, and I think this topic is going to delve more deeper into that model. So I'm waiting I mean to explore that more as
So,
a class new one.
but what have you grabbed so far?
And yes, the we have the probabilistic um, model, and then the graphical model, and I think that's one of the things that's the major component of this topic that we'll be looking at much.
Okay, which two disciplines form the foundation of probabilistic graphical model?
Uh, Statistics, I think statistics is a major discipline, and then there's some type of kind of programming which is computer science.
You just want to bring your own computer into this stuff, which is good. Are you not the one with computer background?
Yes, sir.
Yeah, so we agree with you. It's good. That's fine. So, uh, yes. Let me now come to Abiola. Abiola, are you there? Abiola is muted. Yes. Oyeleye, are you there?
Yes, sir.
Okay, so what do you want to add? I can see two Oyeleye, Timothy Oyeleye, Dupe. That's fine. Go on, Oyeleye, Dupe.
Actually, I'm very conservative with machine learning, and
Okay,
I used to hear about Bayesian network, but I didn't know that it really falls under machine learning. So, but today, from what you said, I
yeah,
realized that the branches of machine learning is really, really wide,
yeah.
and PGM is a good like using the graph theory and the probabilistic theory is a good way of showing the uncertainty.
That's great. So all these fields, machine learning, no, um, PGM, they are all in the same family of artificial intelligence.
Yes, sir.
So uh, the umbrella body is the artificial intelligence, and there you have different other even image recognition, language
Processing,
processing, natural language
word
processing.
processing.
All of these are embodied in the artificial intelligence field. So it's a very wide, field. So everybody just uh, you know specialize in different aspects of the field.
Of it.
Yeah. So
All right,
that
sir.
that's good. Uh, except there is any, yeah. Who is Ade Tono Ade doing?
So,
Okay, Abiola, you are now live.
uh, um, just to add to what a lot of them have said,
Yeah.
you said Bayesian using undirected and probability brings more light to PGM. I think they said virtually all you have said today. So
So
I don't know what you want me to talk about against that.
even if it's possible to repeat all that I've said today,
Uh,
that's the only way I will know that yes.
okay, the Bayesian tools are necessary are for reasoning uncertainties using graph.
You could use
And
your
you
own.
talked
You could
about
use. Okay, go on.
Markov and then the Bayesian and said we are going to be focusing more on the Bayesian. The Bayesian is for the directed edges, while the Markov is for the undirected. You gave illustration, so and you said we'll be focusing more on the Bayesian. I think
Okay,
that's the summary of what you have said.
thank you. So let's
Yes.
let's go back to the lecture notes so that we save more time. But I expect people to ask questions as we go on. Now, well, I seem to have talked about these types of probabilistic graphical models, which I've explained. The Bayesian networks is a directed one. So this is a directed because you have arrows showing the direction. So this is directed. Sorry. Okay. So this is directed. So this is undirected. Linguistic student, I hope you are following this. This is foundational. This is very basic. So what makes it directed is because uh, the edges, are represented by arrow, and you see the flow of influence. So, but this is undirected because the edges have no arrow. Uh, so, uh, so what this section is talking about, these types of probabilistic graphical model is talking about is about Bayesian networks, which have directed graphical, structure, and of course the Markov network, which have undirected graphical structure, right? So let's look at example that is given in the case of the Bayesian network. Here you have example of trying to model whether it rains or not. So you have rain here. So you have rain. Sorry, this. You have rain as a variable, and you have grass, no, as another, and you have sprinkler as another. Now, you want to model whether the grass is wet. So if you have here the grass, what can make the grass wet? The grass can be wet if there is a rain. So rain is a variable because it's either it rains or does not rain. So rain can influence the grass, the wetness or otherwise of the grass. What can also make the grass to be wet? It can be wet, or if the sprinkler is employed, so you can have here S. So for grass to be wet, it's either it rains or the sprinkler is operated. So we can see the cause and effect relationship. So what is the cause in this relationship? Who will tell me what is the cause in this relationship? And what is the effect? Kasaba, are you with us?
Yes, sir. I believe the rain is the cause. The rain and the sprinkler are the causes, and then the grass being wet is at the resultant effect.
You have just won 1 million naira. Are you okay with that?
Yes, sir.
Collect your money from honey, right? So, so the point being made here is that Bayesian networks displays in graphical form the cause and effect relationships. So you could see that rain is the cause and the effect is the grass that is wet. Also, we could see that the sprinkler is a cause and the effect is the grass. So anytime you are building a model, even in linguistics, as we will be seeing later now, even in linguistics, we are interested in cause, when we are interested in cause effect relationships, then we use the Bayesian networks because that's where we can have a directed, we can see the flow of influence, the direction of influence, the cause, and also the effect. So any one in which the arrow points is the effect, and the origin of the arrow is the cause. So you can, this is what we are trying to display here. So that is what is even clearly stated here, that the rain and sprinkler both cause the grass to be wet. But the nodes, that's where you have the variables. So we will talk about the probability, that the grass will be wet if it rains, and the probability that the grass is wet if it's uh, if it's from sprinkler, and that leads us to conditional probability and uh, conditional independence. We will talk about that later. So again, the Markov networks. By now, all of us will be able to make a distinction between the two. In the Markov networks, no direction, but there is a graph. There is a graph, but no direction. And example is further given here. So you have temperature, you have humidity, you have air conditioning usage. Air conditioning usage can have can influence temperature in the room. Humidity can influence temperature in the room, so they can influence one another. Temperature can influence the air conditioning. Humidity can influence the air conditioning. So in that case, you have air condition, you have humidity, you have temperature. So air conditioning can influence humidity. Humidity can influence temperature, and temperature can. So when you have this kind of situation where all variables are related, but not in a specific direction, that is Markov network. So, and that's why arrow is not used to show the specific direction or the uh, the flow of influence. So the way the probability is defined in Markov network is different from the way the probability is defined in the Bayesian networks. In Bayesian networks, conditional probabilities are used. Get that one very right. So in Bayesian, conditional probability are used. But in Markov network, you use special functions. Some specific functions are used. So functions are used. So those are the key features of these two types of graphical models. Any question on this before we move to the next part of this? Yes. Any question? Any question? Nobody. The class is too dull.
Yes, sir.
Yes, ask your question.
I think I would understand the difference between hidden Markov and Bayesian network, because before I used to confuse the two. Like I don't know the difference. I feel like they are performing the same function, but now I think I can differentiate. And then linguistically, I think I know I can I have an um, inkling of where to or what kind of data that we can use for Bayesian from your explanation, sir.
Good. So before I leave you, what are the key differences between these two types of PGM? The Bayesian, it's not just for you to say you know them. Tell me the differences between the two of them.
Okay, sir. You said the Bayesian inference makes use of conditional probability, while
Yes.
hidden Markov makes use of functions.
Yeah.
Then another thing is, you said Bayesian is directed, while hidden Markov is not directed. Those are the two I remember, sir.
So, but I also emphasize on one thing: cause effect relationship.
Yes, sir.
Cause effect relationship, right?
Yes, sir.
What kind of relationship does that belong to? Cause effect relationship?
That's Bayesian, sir.
Bayesian. So what kind of relationship do you have in the Markov network?
Um, the relationship, there's no direction in the relationship. One can just influence the other. One factor can influence the other factor, and there's no um, direction to which one actually cause which one.
Thank you very much. So there is a relationship, so but no direction. There is no direction, and we we, we, we give example of temperature, humidity, and air conditioning. So they both, all of them can influence one another, and that also happen in most natural phenomena. Most natural phenomena, you see, you know, uh, you see things affecting each other. Okay, uh, let's now move to maybe the last segment of our discussion, which is going to focus on the applications of PGM. Uh, so let me share my screen again. So let's start. It's good I even started the application with. So my discussion will focus, on the on the. So we'll focus more on the linguistics, so that our, our colleagues from linguistics will possibly appreciate why we are why you are doing this course, and why this course is relevant to your field. Remember, you are doing computational linguistics, not uh, the linguistics without the computations. So PGMs are relevant. They have applications in virtually all disciplines. It's not no, and I listed quite a number of them here. You can take time to even look at the literature, look at studies, look at applications in health and medicine, in education, in transport and navigation, because in all these areas, when we started, I gave example in education, where we talk about performance being influenced by attendance, assignment, proud grades, sleep habit, and so on like that. In transportation, in navigation, in fact, even the phone that you carry, that's where we will now talk about the linguistics and natural language processing. So PGMs have application when it comes to modeling sentence structure and word dependencies. So in linguistics, though I'm not a linguist, but I also have to do uh, my own research to be able to make this thing very relevant. So there's what we call POS, which is called the uh, part of speech. Am I correct, Cassava?
Yes, sir. Yes, you're correct, sir.
So part of speech. Anyone in this class knows very well that if you have done English before, so you can, in any sentence, you can identify, or tag each word. You can tag each word, whether tag them based on their part of speech. So a good example is if I make a statement that the cat sat on the mat. The cat sat on the mat, and I put full stop. This is a very simple sentence. So we can use PGM for predicting the next word. Even if I just say the cat sat on the, and I stop there, I can use PGM to predict what the next word will be. How many of you have experienced this when you are using your phone? If you have experienced, your phone suggesting what the next word will be, say yes on the chat menu. I mean, almost everybody should be able to say you have experienced this. So an algorithm is actually working underneath. And that algorithm is developed using the probabilistic graphical model. So with probabilistic graphical model, you could predict the next word. And also, you could also do what we call tagging. What we call tagging. Tagging simply is the process of assigning a grammatical category, to each word in the sentence based on its, So if you have in the sentence, like the cat sat on the mat, this is a word, 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 this is a word. In fact, this also is, that is also part of the sentence. That punctuation is also part of the sentence. So tagging involves assigning part of speech, grammatical category to that, to each word in the sentence. So, and when you are tagging, what are the different parts of speech? From our colleagues in linguistics, what are the different types of speech that we can have? Yes. Is anybody talking? What are the different types of speech?
We have the noun, sir. The noun, the
The
verb,
noun, yes.
the verb.
The verb, yes.
And we have the preposition.
The preposition.
Then we have the determiner.
The determiner. That's good. So this is where the two of you will have to work together. Those of you who are in statistics and those of you who are in linguistics, because we will do a lot of this, in our stuff. So here you will see. So what if I'm doing tagging? What will I attribute to D?
Determiner, sir.
Determiner. That will be determiner. What about cat?
Noun.
Noun. So that will be noun. What about sat?
Verb.
Verb.
Yes, sir.
What about on?
Preposition, sir.
Preposition. And D?
Determiner, sir.
Determiner. Mat?
Noun.
Noun. And of course, the last one there is punctuation, isn't it? So
Yes, sir.
you have the punctuation. So this is what we call tagging in machine learning. And sorry, in linguistics. Not, of course, part of machine learning is also about text analytics, where you do text analysis, but that's not our interest now. So we are using, our ultimate goal will be to use PGM to see how we can predict what the next word will be, or when we are doing tagging. So these are the different part of speech. I think we need to. I would love those in maybe this an assignment also. So those in the linguistics to give us the the different part of speech. There are standard expressions for them. There are standard expressions for them. So you get those standard expressions and use them. Or try to, just a minute. Try to explain them. the common part of speech tags that we have. So, for instance, for noun, they use NN. Am I correct? For verb, they use VB. For adjective, which is not here, for adjectives, they use JJ. For adjectives, like if you are saying words like big, red, happy, these are adjectives. The adverb, they use RB. For pronoun, they use PRP. For pronoun, PRP, and so on like that. I leave that to our colleagues in linguistics to generate, because we will be doing much of this later in the course. So, in summary, the application of PGM in linguistics could be to predict next word in a sentence. It could also be to tag the words in the sentence. I don't know if we are already doing so much in our local language, local languages. Do you have idea if something like that is done? Because this part of speech tagging actually helps the machine to 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 recognize human language and translate the language. That's why it's very important. So this POS tagging, part of speech tagging, is needed for machine translation, voice recognition, and so on and so forth. I don't know, maybe Cassava and others can tell us if this kind of tagging is ongoing or already exists for our local languages. Is anybody responding? Cassava?
Yes, sir. I believe some works have been done concerning Yoruba per se, as regards part of speech tagging, though it's not as efficient like that of English language. But then there are some projects that have been done on that, sir.
Because if I'm, for instance, using my phone to send a text message in Yoruba, the phone will still be suggesting English word for for the next, when I'm building the sentence. Do you also experience that?
Yes, yes, sir.
Who is talking? So it only means that we still have a lot to do for local languages, and that's why those in linguistics, those in statistics, those in computer science, you have a lot to do. So for most other languages, particularly the global, languages that are used globally, like French, like English, and so on. You could easily relate with your computer, in those languages, but not much of our local languages. So that is uh, a specific discussion around linguistics and natural language processing. So you have the rest. I leave that to you, health, medicine, and so on. So for this chapter, this summarizes what you are supposed to take away. So PGMs, they are tools for reasoning under uncertainty using graphs. And they are made up of nodes which represent the variables and the edges which represent the dependencies. The Bayesian network and the Markov networks, we discussed the two of them extensively, and we are able to make distinction between the two. So we also look at the application, particularly in linguistics. And I concluded that we need to come together, uh, disciplines need to come together, statistics, physics, and artificial intelligence, to be able to also address the issue around our local languages. So this is the end of the lecture. I will leave you now with Honing and Kafayat to discuss or review the multiple choice questions and also the exercises. You are supposed to work on these exercises and make sure you submit. Before our next meeting, you should be able to read chapter 2. So when I come for this lecture, I'm not going to be the one that will be talking. You also will be, I'll force you to speak based on what you have read. So thank you very much, except you have questions for me. It's almost time, but I still want Tony and Kafaya to interact. You can ask them questions also, in case you still have some questions to ask. Any question before I leave? Timothy Oyeleye, are you there?
Hello, sir.
Hello.
Yes, sir. I want to ask how to get the material.
Yeah, you can get, if you want the copy, yes, you can also come to my office. Maybe that would be better. If you want the hard copy, you pick it up in my office. If you want the soft copy, you just make the payment and send the receipt, and then the soft copy will be sent to you. And then the is passworded, so the password will also be sent to you. Is that okay?
Yes, sir. Thank you, sir.
Great. So let me stop recording now.